Hey folks, thanks for joining me today. I've got with us Wyatt Marshall. He's CTO and co-founder of a company in the LLM evaluation space called Halluminate. Wyatt, super excited to get to hang out with you a little bit, to learn specifically from you as an expert in the evaluation space. Just like kind of to set the stage a little bit and a little bit of background or structure for our audience here. I'm going to assume that viewers have a little bit of a background with LLM evals regarding like the fundamentals, some of the more basic best practices. For those who don't, I highly recommend reading a couple of resources from Eugene Yam. He's an applied AI researcher and scientist at Amazon. He's written some canonical essays on evals, building full stack LLM-backed applications. I'm also going to recommend a massive 128-slide deck on eval fundamentals best practices from Eleuthera AI. They are the open source artificial intelligence research organization. So if you want to check those out, just look over my shoulder here. I'm going to wait for a little bit for dramatic effect, but also, and then here for the Eleuthera AI link. But seriously, folks, if you've got a background as a senior full stack engineer, you can Pareto principle it to get to like 80% of the knowledge around evals best practices just from a couple hours of study reading those resources. About the other 20% of knowledge that's way harder to get and requires a lot of many times frustrating experiences with edge cases and at the bleeding edge. That's why we're talking with Wyatt today. Again, he's CTO and co-founder of Halluminate. They are a startup dedicated to the evaluation space. So, Wyatt, let me introduce myself. Let me introduce OpenPipe, and then I'll let you do a much better job of introducing yourself and Halluminate than I could ever do. So, my name is Reid Mayo. I'm a founding AI engineer at OpenPipe. We're Y Combinator company, YC23. We're a platform that makes it super easy to fine-tune large language models, both open and closed models, big and small models. We do support the full end-to-end process from data collection, logging, data selection, and quality improvement of that data, refinement, running the actual fine-tune jobs, evaluating the different fine-tuned models that you have fine-tuned based off your data set, all the way end-to-end through inference for your convenience as well. We host inference for you, but it's for your convenience. There's no lock-in on that front. If you need to export the models, it's very easy to do that in order to self-host if you need to go there. So speaking to my background really quickly, I've got a very lengthy background as a senior full stack engineer. I've personally built technology from the ground up, scaled it to internet scale, which is kind of a hand wavy, way of explaining experience, but billions of requests, massive data, good at building technology across the full stack. So on the Gen AI side, I don't actually have a traditional background in machine learning, but I've been pretty heavy into the Gen AI space for about a year and a half. Prior to OpenPipe, I co-founded a senior full stack dev shop, grew to a team of 25, worked with a lot of great talent on that experience. It was great, but it's fun, a lot more fun being closer to the actual technology these days, especially working in Gen AI, most novel thing I think I've worked in since I first got into engineering a lifetime ago. So the best place to reach me is LinkedIn. Reid Mayo, OpenPipe, send me a connection request. I'm super friendly. Happy to accept that and just shoot me DMs or we can always hop on a call. So let me hand it over to Wyatt. Tell us about yourself. Tell us about Halluminate.
First of all, thanks for having me here. Really appreciate it.
Absolutely.
I'm excited to kind of, dive into the nitty gritty of evals a little bit. I think it's an underappreciated part of, the LLM development life cycles. Excited to get into that. But before we do, just a little bit about me. So I graduated in 2022 from Cornell. I studied computer science and philosophy, which I think is an interesting combination when you start using LLMs. We can get into that more later, but
sure,
a lot of overlaps between the two.
Yep.
And one of the reasons I got interested in the space, I worked for a startup at Cornell. A couple of hockey players started a company to put sensors on players, skate around, collect some data, do some ML, figure out like what makes somebody a better hockey player than someone else. So that kind of got me into the ecosystem a little bit. And I graduated. I worked for another startup in New York. It was an ad tech company. So we did identity resolution, pretty much responsible for targeted ads. So if you ever Googled something and then got, emails for that, that was me.
Yes,
you're welcome. Yep.
I will say it's effective.
Definitely. And it was actually a really cool job. I learned a ton. Probably had too much responsibility in my role, for being honest.
Sure.
Massive amounts of data and just getting really hands-on. And, it really was a formative time. I think I was ready to leave when it was time to go, but happy for that experience. And it got me to the point where, I felt like I understood a little bit about how a small company can run and operate. And at the same time, my roommate in New York, Jerry, also co-founder of Halluminate, met him freshman year of college, the first week of college, so I've known him forever.
Sure.
And
Awesome.
he was working at Capital One Labs. So building Capital One's first LLM-based application. It was a tool for their customer service representatives. And every day he would come home from work and he would complain about how annoying. He was a PM on the team. He's like, I have to review thousands of these, our customer service reps are using our tools. We don't know if the tool is actually giving them the right answer or not. So I sit there, I look through spreadsheets, I email people who actually know, customer service reps that can tell me if this is right or not, email their responses back to the engineers that are actually building the application.
Yeah.
He's like, that's all he did.
There's got to be a better way.
It's got to be a better way. And so we were, at the same time, we were playing around with all these new kind of Gen AI tools are coming out, Runway. I think this is right around when GPT dropped, and we realized there's just so much potential to use these tools to make our lives easier. And we started messing around with it. We built a couple different prototypes and ended up applying to some accelerators, got into an accelerator out in San Francisco. And, we, at that point, decided like, okay, somebody's going to give us some money to do this, then
Sure.
let's quit our jobs and do it. So that was about 6 months ago. Yeah, obviously, our initial idea is a little different than what we're working on now in the world of startups. Tends to happen, but
for sure,
we were really focused on this manual evaluation problem.
Yeah.
The idea was like, how can you connect the subject matter experts with the engineers?
Yeah.
And we built this platform. We were showing it to a bunch of people. And even within the first few months, we realized like, this is not going to scale. There's just evaluation is too big of a problem, and the space is growing too fast to rely on manual evaluation. So
it doesn't work.
Well,
at least doesn't scale, I guess.
Doesn't scale, exactly. Yeah, you need it. It's essential. And, don't get me wrong, but
I was going to say, as your co-founder, you said his name was Jerry, is that correct? Yeah. As your co-founder, Jerry realized very quickly, manual doesn't scale. Seeing his job at Capital One being basically manual-based evaluations. And then, of course, you're a guy that's basically built, Moneyball, it sounds like, in your past. So you're like, hey, I think there can probably be a better way. Speaking of that better way, man, let's kind of hop into some of these questions. So before we get into the topic of agents and multi-step workflows, what are some of the techniques that your customers, yourself, engineers in your network are using really effectively to evaluate single-turn LLM calls? Again, not even worried about the multi-step problem, which is the huge issue.
Yeah.
More granular. What's working and what's not?
Yeah. I think one of the more interesting techniques that I've seen that it's not really in evaluation, it's really in writing good prompts, but is don't write a prompt to an LLM, write a prompt to another person.
Right.
Like instruct a person, here's what I need you to do, here's how you need to do it, here's what you should be aware of, here's relevant context, here's a couple examples, and write it in a way that another human could then perform that task. And if you can do that well, the LLM is going to do a pretty good job. So I think that's something I definitely don't think a lot of people realize that.
Yeah, I was going to say I've heard of that. I think it's almost like, in fact, Eugene I think might speak to this, and I think he called it like almost like cosplaying like a summer intern. Like, if you could spell it out and add, define it enough and concretely enough that a summer intern could be successful, then odds are an LLM might be more successful as well. So what about like that? Like that's on like the kind of the prompt engineering side. What about on you prompt engineer the hell out of this? You're getting a really good result most of the time based on passing the sniff test. How do you pull Jerry out from after manually evaluating these responses, the generated responses? Like assertion tests, LLM as judge. What are some of the stuff you've seen that's working?
Yeah, I think it's use case dependent. You definitely, if you have a specific enough task that you can get away with assertion, you should use it. It depends on how granular you need the LLM to be and like how specific the response is. I think those are honestly the easier ones to deal with. It's like, okay, I have this task, I give it this input, and I know the output needs to be one of these 5 things, and I know the right one is this one, so I can just check, did it get it right? And that's definitely like the first step, I would say. I think a lot of people don't get to that point because they don't dial their, they don't break the problem down small enough. And I also think the more interesting use cases are the ones where you can't just is this equal to the expected value? Yeah. That's the whole point of LLMs, right?
Task, it's...
I mean, LLMs are cool because they're more powerful, they're more flexible. You sacrifice that determinism, but you gain so much in its ability to handle different kinds of inputs, different kinds of problems. So when you get to that point, I think you really have to make the jump to LLM as a judge. And that's sort of the big leap we made at Halluminate is you can't rely on assertions once you get to a level of complexity, because you're never going to get the expected output. The same input doesn't always give you the same output. You have to get to a point where you have LLMs evaluating LLMs. And, there's a lot of strategies that go into doing that better or worse, improving that kind of pipeline. But I think that's definitely the leap from sort of a basic application to something that's a little bit more advanced.
Yeah, more complex. So on those more complex tasks, do you see people almost building like a suite of different evals for one specific response? So, it might, again, on a sufficiently complex task, how useful is regex matching or keyword matching or any other, classic assertion software test style eval. But even on those complex tasks, do you see people successfully starting with that and then layering on LM, like judge LM based evaluations to maybe gain an advantage from both of those different paradigms? Is that common
No,
is it?
I think I honestly wouldn't say it's common, unfortunately, because I think it is the right way to do it.
Oh, okay.
I think it's uncommon because it's a little bit more challenging. And I think people skip to, okay, test feels good, jump right to the next step. But I think that is the right way to go about it, because when you leave the world of determinism with software, you're accepting the fact that you're never going to be 100% certain that something is going to work, right? So tests become a confidence thing.
Yes.
It's not like, okay, if it passes my test, it will always work every time forever. It's like, if it passes my test, I'm confident enough. It's past the threshold, it's over a bar. And that's really what you can get when you combine those different techniques. It's like keyword matching is a great place to start, right? Or a lot of applications involve producing a structured output. So first, let's just make sure it's a valid JSON. Then let's make sure it has the keys that I expect it to have. Then we can make sure it has reasonable values. Then we can do an overall LLM as a judge. Does this input produce this response in an acceptable, does that look good? Stacking those things is a great way to build that confidence.
You keep speaking about confidence, and I love that word. And in some ways, it's so foreign to software engineering. Realistically, a lot of us got into it because code is the most deterministic thing ever. If you're junior engineers don't necessarily always feel that way. But if you're a senior enough engineer, you always know what's going to happen. And in some ways, that's what draws introverts to software engineering. It's people, who knows how they'll respond whenever you talk to them. But software, I know what to expect. Of course, Gen AI throws that entirely out the window. What I'm hearing is whenever we're modeling these systems with sufficient complexity, we probably shouldn't we should be building around the assumption that we're never going to be 100% certain. So more it's a question of, on the given task, what is my threshold for, a successful response versus a non-successful response? Kind of modeling the system around meeting that threshold. Is that how we should be thinking when we're building these Gen AI apps?
I think so. And I think you make a good point, which is traditional software engineering is the code does what you're telling the code to do. And if there's a bug, it's not the code's fault. It's your fault. You wrote poor code. So getting over that is definitely tough in the world of Gen AI, where it's you can write it well and it might not do what you want it to do. And that's just the nature of, the game at this point. So it really is getting your confidence dialed to a point where you're accepting that whatever risk comes with a bad answer, right? Or an unsuccessful response. You're weighing that against how powerful this new flow or this new application or this new product can be. So I think it depends on the, position you're in, how the product's being used. If it's a really risk sensitive topic, then maybe LLMs aren't even the right way to go. But if they are, you got to be really careful. You got to break it down into really small problems and be really confident in the, the pipeline. Something that's less
potentially.
And
health or financial data that's hypersensitive. Maybe you get it to 98% confidence when you're building your system, which is super valuable because realistically, you're saving a bunch of labor that financial analyst or a doctor or a nurse would have to deal with. And now they're just kind of providing that last 2% of required certainty.
Right. Yeah, you don't have to be perfect in that application, but you would have to have somebody check it over at the end because you're dealing with something that's so sensitive. If you're off by, if it's a financial use case, you're off by some couple
It can be a
$100
small amount,
could
and
be a big deal.
gets
Yeah.
lost.
And that can have a lot of, that can damage a company a lot. So
For sure, for sure. So speaking of building confidence, which to me means one, of course, getting the quality where it needs to be at the level of consistency that is also required. You talked about prompt engineering to build that confidence or build that quality, but does it like kind of differ based on downstream tasks? So like is best performance, and I'm going to say evaluation, but I'm kind of speaking about evaluation and creation of the actual generation. Is best performance summarization evaluation different from data extraction evaluation, which might be different from classification evaluation? And then also in terms of measuring that performance and by proxy our confidence, talk to me about metrics. Like, what are some of the best metrics that you see being used to measure outcomes, I guess you could say?
Yeah, it's definitely use case specific, and even within like summarization tasks, there's going to be different bars, like different levels of quality that are acceptable or not. I think it gets really difficult too in those situations because different real people might have different perspectives on quality and like,
For
this
sure.
is good, this is bad. And so building that in is definitely challenging. I think alignment with like human expectations is a huge part of that confidence. Like you can't be confident in something that's not aligned with what you see as success, right?
Yeah.
So it's a big part of the process. Metrics wise, you can definitely do similar to like traditional software engineering stuff. If you set up a suite of tests and you have your like app running and then you have a judge running or your other checks, like we mentioned, maybe you're checking the keys in a dictionary or something, and you can just score those and you can find, we had 100 examples. We got 98 of them right. Our threshold's 95. So we're happy, ship it.
Yeah.
You can do stuff like that on an actual per call basis. I know like people have written papers about this. I think it's really interesting getting the log probabilities and kind of coming up with a proxy for like how confident the model is
Yeah.
an interesting one. That can go both ways, I think. And you can only really use that in tasks that are like classification or pretty constrained, but that's definitely a good way to get like a proxy confidence score. Seen
Yeah.
that before?
Yeah. I think they call that perplexity. So do you see people using stuff like perplexity or, just averaging the log probs of all the tokens to measure quality of the response? Or do you see them using that almost like, and this is like totally me firing from the hip. Just thinking about like how it purchases a full stack engineer, almost like smoke testing the model. So like if the input space or shape of the prompts coming into this LLM call are, fairly unfocused, we'll say, I might think of using perplexity to like smoke test, like, oh, hey, he's like when it starts talking about this topic, like the prompt involves, this, everything falls apart. The wheels fall off the bus. And then maybe that's a, opportunity to, I don't know, either post-train the model in some way with fine tuning. Probably it's more like you rag in the knowledge in that
Yeah.
scenario. Is that, again, fire from the hip? Does it sound like a decent idea, or have you ever heard about people trying that? Or
Yeah, I think that's definitely something we've seen, and I think it is a decent idea. I think what I find the next layer of that, right, is actually doing the perplexity on the judge. When you take the judge's evaluation, if you can constrain it to like a pass fail or even like a confidence score or an interval, and then you can perplexity on that, that's like, okay, if it's the judge says this is a pass and it's like 0.99 probability of pass, then you're pretty happy that you can kind of be confident. But if it's a little bit less, then you might do something different with that use case. So there's definitely different ways you can use that, but it's an interesting lever to pull.
Yeah. Speaking of kind of like, reducing the evaluation itself to pass fail, Eugene Yan, he talks a bit about this and he says it's almost like, again, the more you can compress the outcomes for pass and fail, the easier it is to actually measure performance. So like he says, like if you can get to binary, so it's like true, this is good or false, this is like a low quality generation, then you can measure pretty easily in an objective way with like classic classification metrics, recall, precision, F1 scores.
F1,
Like out of all the different LLM calls and responses you're seeing evaluated across Halluminate, or again, even just talking with engineers in your network, are people able to get there a fair amount to reducing it down to, or compressing it down to like a binary result? Or are a lot of tasks too complex such that you just can't get there? So you got to reach for something else.
Yeah, I think the goal is to get there. And in most I would say most use cases that we see, that's what you want to compress it to, because that's where you can just be a little bit more data driven and use some of the more traditional methods that people are used to and have lots of experience with.
Yeah.
And so I think a big part of the game is like, how do you take a task? Like, it's actually a good litmus test for the pipeline. It's like, if you have a task that's too complicated to break it down into that, you should probably be breaking the task down and then having that at each step.
Yeah.
Because I think it's similar to like a traditional software engineering paradigm. You want your things to do one thing really well, like classic function. Like, you want it to just have an input, predictable output. It does one thing, it does it well. I think the same's true. A lot of people are using LLMs as functions. Like, the function of the LLM call should return something fairly predictably. It gets tough if you're using something that's like consumer, where it's a user's interacting with it. You have no idea what, that space, the input space gets huge. But if it's in the middle of some pipeline, you probably have a pretty good idea what's going in. You know what you want to come out. You just want to make sure it's putting out the right thing.
Yeah. Regarding throwing some guardrails on, if this is exposed to an end user, especially in a really general purpose sense, like a natural language to SQL or whatever type of context, or chatbot context, do you know a fair amount of people who are throwing guardrails on it by like normalizing the user input? Like, I've heard some techniques where it's like, as they're typing, you give them suggestions to try to like guide them down the same path as either other users that you're getting good quality results on, or just, again, to like kind of normalize the input space or focus the input space when it could be like totally wide open. Is that something that's like fairly common from what you're seeing? And are people having good results with it? Or
I would say people want to do that. I think it's a later, comes later in the process, right? You want to get something up and running first.
Yeah.
That's still pretty, I would say, inconsistent with the results. Like, guardrails generally are helpful and are necessary in a lot of use cases, but sometimes they make the user experience much worse, to the point where it's like actually a
you're losing the advantage of the general
Right. Yeah. And I think there are interesting things we've seen. Probably one of the cooler guardrails, you could call it, we've seen is just like really intelligent caching, and then using retrieval on previous so you have a previously asked question, it was answered well, you save that in a cache, and then you take a new question, you find that, is it similar enough to this previously asked one, pull that, take that answer, and it's like you're saving the inference cost and you're guaranteeing that it's not something that's going to cause a problem. So that's a more like advanced technique, and obviously pretty limiting in some ways, but can be really successful depending on the application. The other thing with guardrails that gets a little tough is when you have to build like custom guardrails. We were working with a company that was a consumer product, and they didn't want it to name any competitors' names. Like, don't refer to any competitors.
Yeah.
And it's like, how do you even build that? Right. Like, that's something that's just tough. It adds another layer of complexity, right? You have to build that, then you have to test that. And so guardrails can definitely be, they're necessary, they're important. They can definitely be tricky though.
For sure. So going back here a little bit, you talked about if you can get away with the straight assertion style tests, regex, keyword matching, awesome. But obviously the super powerful stuff here, the juicy stuff here, that's not really sufficient. So you got to pull in judge LLMs to evaluate the outputs of other LLMs. So regarding judge LLMs, what are you seeing out there that boosts evaluation performance? Like, I mean, there's obviously prompt engineering, the judge LLMs, but like, are there like dedicated judge LLM models that have been post-trained that you're aware of that people have success with? And have you played or know anyone that's played with fine-tuning judge LLMs for performance themselves? How do we make the judge LLM smarter? Like,
yeah, that's the name of the game. Fine-tuning definitely can work. I think if you have a lot of data, you don't even need that much data, but if you have a pretty good idea of what the average kind of space looks like, you can do a lot with fine-tuning. You can get a much better performant judge, and it's cheaper. So there's a ton there. You have to collect a lot of data and make sure that the data is good, garbage in, garbage out. If you have bad data, you're gonna get a bad judge. But that's a major strategy. I think another thing that we see is actually splitting into different criteria. So if you have a task and, maybe it's a summarization task, and you need your summarization to be, the right length, have the right tone, and contain the main topics from the input, you can try and one-shot that in one, like, LLM as a judge call, or you can split that into 3. and you're going to get much better performance if you split that into 3. So that's I would say like the biggest tip I would have is evaluate for one thing at a time. That's like massive.
Yeah, decompose the complexity. Decompose the complexity. Yeah, that's we keep going back to that point because it's like a fundamental engineering approach to get better performance and solve harder problems.
Yeah, and as an aside though, like I definitely try and one-shot stuff with like Claude all the time, and it sometimes blows me away that it knows, I ask it to do 10 things, it does all of them.
Yeah.
But when it comes to the, performance and scalability, you really do want to decompose.
Yep. Absolutely. Absolutely makes sense. What are your thoughts on judge LLMs versus jury LLMs, where, it's kind of like with this attempt to get better confidence, as you put it, which I love, on the evaluation result, instead of having like one smart judge LLM, maybe have several judge LLMs and maybe even have a little bit of diversity there so that each LLM can kind of evaluate it from a slightly different angle. And then vote, maybe the jury pool vote, so to speak. Heard about that? Know about having experience with that, or talk to anyone with experience with that? Is it worth it, or is it totally just like the value is just not there? You're not seeing it.
Absolutely worth it. I think that's a technique we use. I know people that use. It really tightens that distribution of what your judge is going to return because you're just doing multiple and taking the average. You're going to shrink that a little, which is helpful. You want repeatability. I think you're not going to boost net accuracy, right? Like if you throw one judge or 5 or 500, you're never going to make that judge 100% aligned, but you can make it more repeatable and more constrained on it's going to give you the same answer every time for the same input, which it should.
Yeah.
I think going even further than that, there's a lot of interesting research in this space on LLMs preferring their own generation, like GPT-4 preferring GPT-4. So mixing the actual LLM, like the foundation model, is important. And I think if you have like a jury and you have different models that can help sort of negate some of that bias, that's definitely important. And then even going kind of like in the experimental realm, all right, what if you have a bunch of small LLMs, like SLMs, and then you have like this, that's kind of your jury or like democracy, and then you have like a powerful leader LLM that's kind of making the overall call. So there's a ton of fun stuff there that I think needs to be researched more. But we've played around with benchmarks, and
what have you seen?
There's definitely potential. You get the cost goes up, right? Cost and latency goes up, and so there's trade-offs there, but accuracy goes up too. So
in terms of accuracy going up, is it kind of like marginal at that point? I mean, it all adds up, like going from one smart LLM to the jury pool pool democracy style with maybe a smart LLM, picking from those responses instead of just doing a naive vote, max vote call. But do you, if firing from the hip or throwing numbers out there, what type of kind of performance boost do you see doing stuff like that?
Yeah, it's marginal, but when you get up to 70 plus, you're really
every percent counts.
You take what you can get. I think we've seen probably in the best cases like a 10% boost, which is massive, especially at that end of the scale. Usually you don't get that, but it can be huge. You are trading off. It's more expensive. It's going to be slower, but in some cases that's worth it. I think you do have to play around with it, and you do have to figure out what you're comfortable with and where you're happy making trade-offs. But I would say it can absolutely be worth it, especially when you're getting to the point where you're adding a 3% increase in our alignment is huge.
Yeah, absolutely agree. Okay, let me recap here. I think we've talked about, we covered a little bit of prompt engineering, or at least decomposing the criteria of what you're evaluating on, and maybe separate prompts. And then, of course, each one of those prompts can tie to either one smart LLM or a jury of LLMs or a democracy of LLMs with the president at the top making the calls. We also talked about specialized LLMs in terms of fine-tuning the judge LLMs themselves. Am I missing anything? Not that we haven't talked about already, but what are some other techniques that might move the needle on, even if it's marginal, even if it tacks on another percent or two? What else is out there?
This is one I think it's pretty public knowledge at this point, but reflection. So I'm sure you saw O1, it does chain of thought, and kind of a little hack for chain of thought is have an LLM evaluate and then ask it, are you happy with your evaluation? Or, even ask another LLM. And at that point, you're like, is it turtles all the way down? Or are we just going to keep doing this? But
I'd say that.
But it actually can boost like a few percent. It's a weird thing. I'm sure there's research behind it, but I've just found it to work. And so like we use that all the time.
That's what I care about. Like,
Yeah.
I want you got the applied experience.
Yeah.
That's what I want to hear about. Like, I don't care if it's like mumbo jumbo or it sounds like black magic. If you found something to work, that's what I mean, I'm an engineer. Like, I'm not a,
No, so similar off that, we actually found an effective strategy is you take prompt for a judge. So, evaluate this based on whatever. And then you have you can do this manually, but you can also have another LLM call to generate evaluation questions. So, hey, given this task, like here's your judge needs to do this. What are some questions that would help get to that evaluation? And then you do the reflection, so have the judge make the evaluation and then ask it the follow-up questions. And that, again, it's like, it feels like it's cheating. It doesn't make sense, but it works. It just gives you better scores. And so I've definitely seen that. I've definitely seen that be effective, which is interesting.
Love it. Wyatt, let's get a little bit more complex here. So we've kind of talked about the single step, how you evaluate a one LLM response a variety of different ways. Let's talk about agents. Let's talk about multi-step, multi-turn agent sequences. But to, again, try to decompose the complexity a little bit here, let's put RAG aside for now. Like, I know that, like, obviously RAG is going to be involved in just about every agent under the sun, but that adds in another layer of complexity. So putting aside RAG for now, and we'll get to that next, but just like a classic multi-turn AI agent, how do we evaluate performance of the system to make sure that, like, it actually stays on track instead of getting thrown off by compounding errors? And then ultimately, how do we evaluate that it ended up with the desired result or output? Again, that's like an abstract question. Like, keep it applied. Like, what are you seeing? What are you hearing people do that actually works? I don't care if it sounds silly. If it works, that's what I care about.
Yeah. I mean, it's just another level of difficulty with evaluation. Like, going into that world, I think, it makes things so much harder. Like you said, just going from single to multi-step. And then when you get to the point where you have like tool calling and you have sort of like an unconstrained or even agents working together, it gets so much harder to evaluate. With that, there's definitely a lot you can do with just kind of recording logs and then analyzing logs, like using an AI obviously to do that. I think it's the first step when you get into that kind of architecture.
Yeah.
I honestly haven't seen many people even really building like production applications that are truly agentic yet. I think there's a barrier before people are going to be comfortable like releasing stuff. We've seen like some proof of concept and some demos that are pretty impressive, but evaluations there and benchmarking, that's the performance of those systems is just so much harder. Just takes a lot more. It's a lot more manual. I think automating it is going to come next, and it's coming. But you got to be a little bit more manual with it, and you really do need to pay more attention to like output, like log outputs and the log traces, and go from there.
So one thing that kind of comes to my mind, if you're talking about it being the evaluation being really manual today, but then this almost goes back to the start of our conversation where we were talking, and the thought here was, how do you create a system? It's probably going to be LLM based, but how do you create a system where basically the judge or eval LLM or series of LLMs is aligning with the human? And I mean, obviously that's the objective there. So is there a path where the AI agent is running in production, you're logging everything, like you said, all the traces, and then you're having your human, you're having Jerry pop in there and manually evaluate, the results, the performance, and so forth. Is there a path to building a parallel agent that is basically just like an evaluation agent? So you've got like your applied agent that's doing the task and making decisions, doing the workflow, and then you've got a side-by-side evals agent that is almost like constantly grading each step in this multi-turn sequence. And the goal, of course, is to align that evals agent with Jerry's judgment as it goes along. Are people doing that yet? Is that the way to do this? Like,
absolutely, people are doing it, and Yeah, like we see it, we call it, like a supervision agent. It's almost like if you have if you're going to personify it, you have an employee has a supervisor making sure that they're doing their work well and
Yeah.
getting the things done they need to get done. It's the same
Yeah.
analogy for, agentic workflows. Like you have this agent, it's making decisions, it's doing things. And then you have this other agent that's just making sure that the decisions it's making make sense and it's not going totally off the rails. I think that is the future. That's where we're going.
Yeah.
I'm excited to see in the next, the space moves so fast. I'm sure this conversation is going to be worthless in a few months because it's going to, we're already going to
Sure.
be there, but I'm
Don't you
excited to
worry.
see
We
how
posted
that gets better.
much faster than a few months from
All
now.
right, good.
But
Yeah.
are people seeing with those supervisor agents? Are they seeing success, and what does the success look like in terms of size? And again, like in this space, marginal gains matter.
Yeah.
Like we're gonna keep unlocking new techniques and then layering them on, and then in aggregate, we're gonna end up with a great performing system. But what type of gains or performance are people seeing with these supervisor agents today?
Yeah. I would say the most common architectural pattern is the human in the loop, where it's like instead of a human monitoring the LLM in real time and making sure that it's doing what it should do, and then the model, the agent asking for help when it thinks it needs it, you
Yeah.
have this sort of intermediate agent, and that's maybe catches 90% of the time that the agent doing the work makes a mistake or needs help. Like the supervisor agent can handle it, but then it can also call in a real person when it needs to. So we see that, and I think that's the bridge, I would say, towards full autonomy.
Yeah.
But right, the goal is to get the human out of the loop. So
Yeah.
moving away from that, I think it's going to be a challenge. But progress is being made, so it's just a matter of time.
Yep. And also there's value there. I mean, to me, that's basically the Waymo model currently. It's like, the fully automated self-driving cars, for all we know, are driving 99.9% of the time, but, they do have human remote pilots that, get it out of those edge cases and issues. But the advantage there is, I just, again, far from the hit there, but you can maybe have one pilot piloting 50 cars or 10 cars, or maybe it starts with 10 cars and then it gets to 50, then it gets to 100, and so forth. That human in the loop, maybe it's one person that's backing 100 agents that are live at any given time. That's pretty interesting. What are some of the techniques that people are using to get better performance out of the supervisor agent? I've heard of stuff like instead of the supervisor agent like making quality or failure calls per se on the output of the applied agent results, it does that. But also, I've heard they ask the supervisor agent to explain its thinking or explain its reasoning, so you can build like a kind of a theory of mind of the supervisor agent, why it's making the decision that it's making, especially if the decision is more subjective. It's not like that binary, yes, no, true, false, fail, succeed outcome. And then you can take that reasoning and try to align it with the human's reasoning, so as best possible. Is that something that you've heard folks trying, or?
Yeah, no, that's a strategy. We use it. I think it's the best way to go about it right now. It's not as cut and dried as like a thumbs up, thumbs down, right? You're obviously introducing more complexity to the system, which isn't always the best decision, but you can go pretty far with like an evaluation that's more, an explanation, right? Like explaining the reasoning, and that it goes both ways as well. Like the agent being evaluated can use that to like regenerate, improve its whatever step it's working on. And then you also have the human that can read that, and it tries, adds a little explainability to like an otherwise black box system.
Yeah. Yeah. Kind of helps with debugging potentially, so to speak, debugging, optimizing the supervisor agent. All right, let's pull in RAG. So how are people evaluating, multi-step calls? Like RAG gets pulled in. Obviously, like RAG grounding is one of the best ways to reduce hallucinations, but only if the RAG is high quality, such that you aren't like ragging in hallucinations. In the real world out there, in the applied world, how are people evaluating RAG quality best? What are some of the different techniques you've seen? What works? What's the best? What's marginal but worth exploring?
Yeah, RAG is definitely an interesting, I think it's an essential approach, right? Like everything that's being built that really is doing stuff that's difficult is using RAG.
Yeah.
And I think the best systems we see keep the retrieval completely separate from the generation. and like evaluate them completely independently, treat them as just like entirely modular systems, and then you only combine them after you hit your like, yeah, we're happy with both sides. Like we have our retrieval and we're only checking retrieval and it's doing well. And then when we give the model perfect context that we hand feed it, it's doing well. So now we can put them together. And I think that's really important. Like doing that before you do end-to-end evaluation, you just need to do that. You need to be confident in each on its own before you can really check them together, because it makes debugging so hard. If it gets an answer wrong, you're like, did it get the answer wrong? Did it get bad context? Was it both? That's where those challenges are huge. So retrieval stuff, I'd say the most successful approaches we see involve doing it separately and really making sure that that's its own modular system. I think within retrieval, there's so many optimization techniques like you can go with, and when you do them and you keep them as part of the retrieval system, you're going to get a lot better performance. When you start to mix and cross over, it just gets hard to untangle that.
Separation of concerns, brother.
Yeah.
So let's talk about humans. What are the implications around human involvement in the beginning when you're building your eval system? Do you advise or see people, and maybe this is not a good use of time, like humans being involved in building an initial gold data set for like reference, to do reference-based evals, to sort of like maybe bootstrap quality or confidence of your system before data starts flowing through it in production, and then you can really actually start measuring and knowing if it's working. How are the humans involved like at the beginning in the ongoing building of the system, and then once it's launched, once it's in production, once data is flowing through it, what are the implications around human involvement for like maintenance and continuous improvement of the eval system?
Yeah, and I think that's really important because we've brought this up a couple times, but it really is all about the data. And data quality is going to determine everything else. That's the foundation. So having a good, you mentioned like a golden data set is, I would say, the single most important thing for evaluation and just for building trustworthy systems generally.
Yeah.
That almost always starts with putting your head down and spending some time coming up with examples or taking examples from, like some old logs or whatever, and coming up with the right answers. And even if it's just 5 or 10, like, even if it's just a few, if you know that they're perfect, it can take you really far. And that's like where you have to start. And then from there, I think, I'm actually curious what you guys do with like with fine tuning, because synthetic data generation is getting a lot better and has been shown to help. So I think, we see that as well. It's like build your seed and then grow a little synthetic data set that's, it's not as good, but gets the job done. You can still boost performance on evaluation there. And that really is where you get started, right? And then kind of the in-production monitoring piece, you're always keeping an eye on the logs. You're always making sure that like random spot checks look good. I think setting up, we see this where it's like 10% of every call we run an automated eval on and track those metrics. And if we're getting, stuff wrong, we get Slack alerts, we get emails. So having sort of like alarms in place that can catch stuff after the fact, but at least you're alerted that things are not going smoothly. That's really important too. Because you do have to keep an eye on it. It's not like a set it and forget it. It's good to go. You got to kind of monitor.
Yeah. Data drift, of course, occurs. I've kind of heard of that as a reality of, like, for example, I've heard that it's basically impossible to completely eliminate hallucinations, especially in a totally general purpose task.
Yeah, I would agree.
But what you can do is you can, you have your eval system in production, you're taking a sample of, of the LLM traces that are flowing through it, you're running your evals on those, and you can't always detect hallucinations, but you can detect whenever like material changes occur.
Yeah.
Whoa, like, this was passing our evals with 90%, confidence, or 90% of the LM trace were passing before. Now we've dropped to like 70%. So like something weird is going on. And at the very least, you get a flag to have a human go in there and check it out, and see maybe the inputs have changed, maybe your users have changed, maybe if you're using like OpenAI's, closed source model behind an API layer, like maybe they changed their model without telling you.
Totally. Yeah. Or they deprecated it and you plugged in a new version and it doesn't behave the same way. Yeah.
Yeah, for sure. Awesome, man. Hey, so we're almost out of time, but I do want to have one last question for you before I let you get back to it. Wyatt, what are some of the best resources to learn about how to build high performance LLM evaluation systems? Like, do you have communities that you might recommend? Other resources? Where do you go to stay on top of best practices in the literature outside of like the people you know?
Yeah. You already mentioned him, but Eleuther AI is great.
Awesome.
Yeah, that's a great
Validating.
community. I'd say this is something that I find exciting is the LLM research that's being published is pretty accessible. I think keeping an eye on, stuff comes out all the time and you can't read every paper, but keeping an eye on like just new papers being published and what's kind of trending on Twitter, on LinkedIn, and then skimming those or reading those is really important because the field's just moving so fast. And I think there's obviously a threshold of like understanding that you need to be at before you can really get stuff out of reading one of these papers. But I'd say if you're like listening to this right now, you probably have that. So
Sure.
just keeping an eye on like the stuff coming out of research labs is huge. I think you have to do that. Like you're gonna miss stuff if you're not. And then I think to that point as well, it's like LinkedIn, you're gonna get some good stuff, but you kind of got to be on Twitter. You got to be on Discord channels, and being parts of those discussions is really important.
Awesome. Out of the Discord channels that are your kind of usual haunts, anyone in particular that's a favorite?
Yeah, I mean, Luther, awesome.
Okay.
Yeah, I would say also actually Grok does a great job of like promoting. There's just a lot of good discussions that go on in there. Together AI has a good channel as well. Similar, they're, a little like the discussions don't always tend to be around evaluation, but they happen to, the ones that are really good.
Yeah. Cool. Good to know. And speaking of super smart experts to reach out to learn more about evaluation best practices, Wyatt, what's the best way for our audience to find and connect with you?
Yeah, LinkedIn, you said it too, but I'm on there all the time. I always respond. So find me on LinkedIn, Wyatt Marshall.
Yeah, I mean, you got a pretty awesome name, unique name. So I'm sure people can find you pretty easy. Awesome, man. This has been incredibly insightful, incredibly illuminating. I was maybe even trying to make a pun there about like halluminating or something like that. I don't know if I'll go there. Maybe that landed, maybe it didn't. But yeah, on that note, Wyatt, this has been great. Thanks for spending some time with me. I've learned a lot and had a wonderful time speaking with you. So I'm gonna let you get back to it, man.
Reid, thank you so much. Really appreciate it. Great talking to you.
Yep. Likewise. See you, Wyatt.
All right. Take care.